The challenges associated with testing large assemblies such as aircraft or large vehicles are related to the large footprint of the test equipment that's got to be used, the difficulty in rolling out that test equipment into the assembly, and also the massive interface harness between the test system and the product, and the related costs to do with maintenance, time taken to hook up, the time taken to actually run that test. We've addressed those challenges with the real-time scanning system by evolving the large typical traditional test systems into the RTS, nanosat and microsat series. The test equipment or the test points that would have traditionally have been housed in a rack are now housed in the nanosat, taking the test points right up to the harness and eliminating to a large extent the interface cables.
Traditionally, an e-tester system would have a mass of harnesses that have to run from the test console into the unit under test and then distributed throughout into every connector that's required. With RTS, what we've done is we've replaced that mass of harnesses with a single umbilical cable. So that single umbilical cable then runs into the unit under test and provides mag connectors for quick hookup of individual satellites. By moving the satellite test points into the unit under test, this means that that mass of harnesses is suddenly reduced to a single umbilical. The MCM is the brains of the RTS system. The MCM provides the measurement capabilities and also allows connection of the umbilicals. Single umbilical can be used, up to 4 can be connected per UCM. What we've done is we've taken this and we've miniaturized it. This is the microsatellite. 360 test points with 6 separate connectors to connect to the unit under test. And then the next level, the nanosatellite. Nanosatellite, even further miniaturized, 32 test points or 60 test points depending on variant. Nanosatellite has a bulb on the back. The bulb inside has a tricolour LED, allowing us to create multiple colours to indicate to the operator really quickly the status of the connection. Here we have an LRU which is designed to go directly into the errant bays in the avionics bays of the aircraft. LRU is actually a microsatellite or nanosatellite inside a different form factor case with its interface harness going directly to the errant connector at the back. LRU is designed again for very quick hookup, so similar to the single umbilical idea. Now the umbilical can go in and out directly onto the LRU, thereby creating a chain of LRUs to go down the aircraft. Each LRU has an indicator, so the same as a nanosatellite has a bulb on the back, the LRU has a single indicator which can give early indication of whether the test points are passing or failing. The single red light there means that one or more test points are failing the test. So the operator has a quick indication of this is the LRU that's failing and this is the point to look at to diagnose the fault. The mag connector has been designed for rapid connection and disconnection to the umbilical. Prevents damage by accidental disconnection. And also allows the fastest hookup time for the system. Magnets are polarized and there is also a keyway. So if you attempt to connect the wrong way, you feel the magnetic polarization, quick indication, which also helps for blind hookup. So with the active XREF system, the microsatellite is reading an interface ID within this interface harness. The microsatellite is detecting that the harness is plugged into this connector and thereby reconfiguring the test program so that it is testing from here to here. The importance of that means that I can move this harness to any connector on the microsatellite and it will be automatically disconnected from the test program, recognize that it's not being tested anymore. And then when I plug into a different harness, different connector, the ID chip's picked up straight away and the software then starts testing from this test point to this test point. from these test points to these test points. Okay, if I move it back, again to prove it can go into any of these connectors, and once again the software will pick up that the ID's moved and now be testing from here to here. This allows ultimate flexibility and maintainability and availability of the system. In addition to that, mag connectors have been designed so they're all identical. So if I disconnect the microsatellite from this mag connector, I'm then able to then plug it into any available mag connector, and it's picked up by the system and immediately starts testing again. Every module, nanosat and microsat within the system includes a 4mm test socket for probe capability. The probe allows the operator some advanced diagnostic functions like single point testing, self-testing, or inclusion in the test program for testing a test point where the connector interface may not be available. Okay, so as a demonstration, I've got 3 wires that are being tested across here that I'm able to break. The rest of the wires are internal to the test box. So if I remove the blue wire, you can see immediately red indications on both sides saying that that is where the failure is. Remove the green wire, same happens with these 2. Remove the red wire, same happens down on the microsatellite. Again, adding them back in, you get real-time indication of a failure.
Umbilical connections are also interchangeable. The RTS system automatically detects the change and resumes testing.